fascinating than the last. Anyway, a late disclosure has caused a significant split between researchers as they inspect the information. Now, the hotly anticipated snapshot of clarity has shown up as famous astrophysicist Neil deGrasse Tyson reveals the stunning discoveries in space. Join us as we investigate how Explorer 1 identified 500 obscure articles passing through space and discover Tyson's considerations on this amazing revelation. On June 30th, 198, a stony space rock crashed into Earth, striking a city in Siberia, Russia. The strong effect of this occasion brought about the leveling of around 2,000 square kilometers. The significant extent of this occasion resonated overall, causing a worldwide shockwave. Resulting research prompted the publication of The Implicit Alliance Among Astronomy and the Military by Neil deGrasse Tyson, wherein he highlighted the combination of logical investigation and public security, supporting for expanded interest in space investigation to defend our planet. This exceptional work reformed public mindfulness surrounding the significance of room investigation. In an astounding turn of occasions, NASA's space apparatus Explorer 1 has just identified 500 obscure objects passing by in space, leaving researchers puzzled. Neil deGrasse Tyson, the incredibly famous astrophysicist, has once again arisen to give genuinely necessary clarity. However, as researchers dug into the mystery of these 500 unidentified items, they coincidentally found a shocking disclosure about Explorer 1 itself. But before we investigate that disclosure, we should first acquaint ourselves with the noteworthy Explorer 1 rocket. Explorer 1, the brave space pioneer, has presently gone over an amazing 145 billion miles from Earth. The speed at which the rocket goes through space is truly bewildering, covering a distance roughly 3.6 times the space between the Earth and the Sun every year. However, there's another side to the interstellar test than only its speed, lifespan, and distance from Earth. Explorer has sent several groundbreaking disclosures to us, like the new 500 obscure articles it distinguished out there in the immensity of space. These are unusual heavenly objects that we've never seen or recognized before. We'll get into that huge reveal in 1 minute, but there's an inquiry that's likely at the forefront of your thoughts at the present time. How might a rocket that was sent off way back in 1977 still be working and conveying such noteworthy data? Well, the answer lies in the staggering designing and premonition that went into Explorer 1's plan. One of the key privileged insights to Explorer's lifespan is its double-redundant PC frameworks. Each Explorer rocket, including Explorer 1, was outfitted with 2 arrangements of Command PC subsystems, the Flight Data Subsystems, FDS, and the Altitude and Articulation Control Subsystems, AACS. This overt repetitiveness filled in as an essential protect, permitting consistent advances among frameworks and the capacity to enact lethargic PC parts, in this way extending their life expectancy. The PC frameworks on board Explorer 1 and its twin Explorer 2 were coordinated as a dispersed framework with 3 double-redundant sets of PCs. This overt repetitiveness guaranteed that regardless of whether one framework fizzled, the other could dominate, forestalling strategic disappointments. To utilize limited power sources, Explorer's instruments depended on engineered logic. This means that the PC frameworks were planned with rearranged design circuits to guarantee that they could work within the requirements of force budgets and time limits during the rocket's development. Yet, power the board is vital in supporting Explorer 1's operational integrity. The rocket's distance from the Sun, where it can harness solar energy, poses a significant challenge to maximize power efficiency. Engineers had to come up with innovative approaches to conserve and enhance power usage. The power the executives' method utilized by this noteworthy man-made test is genuinely remarkable. One critical part of power the executives includes selectively shutting down unessential frameworks. Engineers carefully evaluate which parts or subsystems are not essential for the primary mission objectives. For example, heaters associated with certain logical instruments have been deactivated. These heaters were originally intended to maintain the instruments at specific temperatures for optimal performance. By switching them off, power consumption is significantly reduced, thus extending the space apparatus' overall lifespan. This decision to shut down unnecessary frameworks isn't messed with. It requires a careful evaluation of the compromises between power preservation and the logical objectives of the mission. Engineers collaborate closely with researchers to ensure that deactivating specific frameworks doesn't compromise the quality and availability of logical information. The goal is to find some kind of balance that maximizes power efficiency while maintaining essential functionality. But that's not all. Explorer 1's power, the board systems also adapt to the changing conditions of its environment. As the shuttle journeys farther from the sun, the available solar energy decreases. To compensate for this, Explorer 1 adjusts its power usage accordingly. This adaptable approach ensures that available power resources are efficiently allocated to support critical operations and information transmission. Throughout the years, there have been ongoing technical advancements and improvements in power the executive's techniques, allowing engineers to refine and improve the power systems of the Explorer tests. These improvements include more efficient power distribution, further developed battery charging techniques, and advancements in power regulation and control. Thanks to these fastidious power the board systems, engineers have successfully expanded Explorer 1's operational lifespan, enabling it to continue its noteworthy scientific journey through the universe. Considering that the rocket was initially intended to last for only 5 years, the fact that it's still sending back information almost 50 years later is downright amazing. It highlights the commitment and expertise of the scientists and engineers who have worked diligently to keep Explorer 1 functional. However, even with this careful preparation and engineering, the depths of deep space remain unpredictable. Stay tuned, because a significant revelation is coming. What did Explorer 1 find? What did Explorer 1 find that stunned researchers? While there are some broad assumptions for what Explorer may first experience, meteoroids, space rocks, and space rocks, there's always the potential for startling amazements. One such surprising curve in the Explorer 1 excursion was the space apparatus claim of distinguishing 500 puzzling objects. This disclosure caused all in all a mix and raised significant worries among the analysts dealing with the undertaking. These strange signs and peculiarities in the information came as a complete shock. Explorer 1 began communicating telemetry information back to Earth, but the readings were strange, and there was no unmistakable clarification for what was going on. The researchers labeled this peculiarity an enigma, but despite the wrong transmission, Explorer 1 proceeded to answer orders from Mission Control, albeit with a slight delay in communication. This was a bewildering circumstance, and it grew the mystery. What was particularly bewildering about this oddity was that it didn't set off Explorer 1's onboard issue security frameworks. These frameworks are intended to activate when anomalies are distinguished, placing the shuttle into an experimental mode that allows engineers to investigate and analyze the issue. In this case, however, Explorer 1 proceeded with its operations without entering experimental mode, adding to the interest. After comprehensive examination, the peculiarity was traced back to the Altitude and Articulation Control Subsystem, AACS. The AACS plays a critical part in definitively arranging the space apparatus and controlling its movements. Approximately 22 minutes for a radio signal to travel one way between Earth and Explorer 1. This significant time delay poses challenges for real-time communication and command execution. Despite these challenges, the mission team successfully implemented the fix to redirect telemetry data to the functioning onboard computer. However, the process was not without its complexities. Given the vast distance between Earth and Explorer 1, even simple communication commands took considerable time to reach the spacecraft, and the subsequent response likewise had a significant delay. Nevertheless, the fix was eventually executed, and telemetry data began flowing through the correct channels, providing clearer and more accurate information about the space environment surrounding Explorer 1. With the anomaly resolved, scientists could now focus on analyzing the data collected by the spacecraft. As researchers delved into the telemetry data, they made a startling discovery. Among the 500 unidentified objects detected by Explorer 1, there was a subset of objects exhibiting highly unusual characteristics. These objects displayed erratic movements, irregular shapes, and unusual spectral signatures, unlike any known astronomical phenomena. Initially dismissed as instrumentation errors or noise, further analysis revealed consistent patterns in the behavior of these anomalous objects. They appeared to defy conventional explanations and challenged existing models of celestial dynamics. Scientists were baffled by the nature and origin of these enigmatic entities. The discovery of these mysterious objects sparked intense debate and speculation within the scientific community. Some researchers proposed exotic theories involving extraterrestrial intelligence or advanced propulsion systems, while others remained skeptical, advocating for more conventional explanations. In light of these findings, Neil deGrasse Tyson weighed in on the significance of Explorer 1's discovery. In a series of interviews and public statements, Tyson emphasized the importance of maintaining scientific rigor and skepticism while exploring the unknown. He cautioned against jumping to premature conclusions and urged researchers to conduct thorough investigations before drawing any definitive conclusions. Tyson's measured response to the discovery of the mysterious objects helped temper sensationalism and encouraged a methodical approach to scientific inquiry. He emphasized the need for continued observation, data collection, and analysis to unravel the true nature of these enigmatic phenomena. In the months following the initial discovery, scientists around the world mobilized efforts to study the mysterious objects detected by Explorer 1. Observatories, space telescopes, and ground-based instruments were trained on the regions of space where the anomalies were observed, gathering additional data to complement the spacecraft's observations. Gradually, a clearer picture began to emerge as scientists pieced together the puzzle of the mysterious objects. Through meticulous analysis and collaborative research efforts, they uncovered clues about the objects' origins, compositions, and behaviors. While many questions remained unanswered, each new discovery brought scientists closer to understanding the nature of these cosmic enigmas. As the investigation into the mysterious objects detected by Explorer 1 continues, scientists remain committed to unraveling the mysteries of the cosmos. Their dedication to exploration, discovery, and understanding serves as a testament to the human spirit of curiosity and discovery. In conclusion, the discovery of 500 unidentified objects by Explorer 1 represents a watershed moment in the history of space exploration. It has challenged our understanding of the universe and opened new avenues for scientific inquiry. By carefully studying these enigmatic phenomena, scientists hope to unlock the secrets of the cosmos and deepen our understanding of the universe's complexity and diversity. Hours for an order to come to the shuttle. This time defer adds a layer of intricacy to speaking with Explorer 1. The mission group must cautiously plan and execute orders, considering the expected reaction time. Any mistakes or issues can bring about unexpected setbacks and complexities. During the inconsistency examination, this time delay represented an exceptional test. It meant that symptomatic and investigating processes were fundamentally delayed. Orders must be painstakingly created, keeping in mind the 22-hour waiting period before getting any affirmation or reaction from Explorer 1. But here's the unbelievable part. Notwithstanding the huge time defer, each message sent to Explorer 1 was not simply adding to the information. It was an indispensable piece of the mission. The time delay might restrict ongoing control and association, but it doesn't lessen the meaning of the correspondence. Each message was a critical piece of the puzzle in settling the abnormality. In the end, the peculiarity was fixed at its source, and the flawed PC was shut down. Explorer 1, the glorious shuttle, could then forge ahead with its staggering excursion through the vastness of space, sending back valuable information and insights to Earth. Now that we know the past glitch of the space test has been settled, let's see the striking achievements of the spaceship when it had no issues. The essential target of the amazing rocket sent off on September 5, 1977, was to investigate our nearby planet group. Yet, its process stretched out past that underlying reason. Explorer 1's story began with a novel twist. A long time before coming to Jupiter, it began communicating pictures of the gas giant. These early pictures displaying Jupiter's radiant whirling mists and the infamous Great Red Spot were an instant hit at NASA's Jet Propulsion Lab. However, this was only the preface to an excursion that would redefine space investigation. What truly set up for the explorers' earth-shattering perceptions was the discovery of active volcanoes on Jupiter's moon, Io. This honest moon, somewhat larger than Earth's moon, held a surprising secret. It was the most volcanically active body in our entire planetary group. Explorer 1's instruments detected particular signs from Io, and the distinctive images it captured revealed a universe of towering volcanic peaks and a surface scarred by the discharge of volcanic material. Among these, Pele, one of Io's most prominent volcanoes, has erupted as high as 30 times the height of Mount Everest, covering an area almost the size of France. The secrets of our solar system were unfolding before our eyes. Prior to the new mind-bending discovery of 500 unknown objects passing by in space, the twin explorers had been wowing us since their send-off. Quite possibly, their most astonishing discovery was the presence of Jupiter's rings. These delicate rings, while faint, added an atmosphere of persona to the already confounding gas giant. Explorer 1 added one more part of the puzzle by uncovering that Europa, one of Jupiter's 53 named moons, was encased in a cold shell north of 60 miles thick. This challenged our previous assumptions about the nature of distant celestial bodies and sparked a new wave of interest in the potential habitability of icy moons. But there's more going on. As the explorers bid goodbye to Jupiter, they got a pivotal goodbye gift: a gravity assist. This gravitational lift, like an infinite slingshot, propelled them towards Saturn. Without it, they would have been trapped in the sun's gravitational grasp, unable to wander further into space. Explorer 1's path took it near Saturn's fascinating moon, Titan. Covered in an orange murky air, Titan's secret mixed scientists' interest, prompting in-depth investigations of its complex chemistry. Explorer 1 then set its course toward the north, leaving the plane of the planets and beginning a journey beyond the planetary group. Amidst all these revelations and wonders, there was one person who played a significant role in extending the missions beyond their initial goals: the eminent cosmologist, Carl Sagan. As a member of the Explorer mission's imaging team, Sagan enthusiastically advocated for one last set of pictures before shutting down the space apparatus cameras. These pictures, he believed, would be a keepsake to humanity, offering a final view of our home planet from the depths of space.